Alright, so in this video we're going to look at ionic equations. There's a few different ways they can ask this, but in the first examples I'm going to look at, I'm going to give you the full equation and then ask you to turn it into an ionic equation. Doing this, you need to decide which of the following species are going to split into ions. As a general rule, ionic compounds, which is a metal and a non-metal, that are either molten, and you'll see that with the state symbol L, or aqueous, which you'll see with the state symbol AQ, they will split into ions. Acids and alkali will also always split into ions. If it's covalent, it won't split into ions, and if it's ionic and it's a solid, again, it won't split into ions. So if we have a look at the equation that I've written here, the first thing I've got is chlorine, Cl2. Cl2 is covalent to non-metals. Because it's covalent, it doesn't split into ions, and I write it down exactly the same way as it is above. The next one I get to is potassium bromide. Potassium bromide is ionic and it's aqueous, so ionic aqueous compounds split into ions. So potassium bromide contains the potassium ion. Potassium's in group 1, the potassium ion has a +1 charge. It also contains the bromide ion. Bromine is in group 7, the bromide ion has a minus charge. Now because I have a big 2 in front of the KBr, when I split this up, I'm going to get 2 potassium ions and 2 bromide ions. That big 2 refers to the K and to the bromine, so I'm going to be putting it in front of both. I get to the next side and I end up with potassium chloride. Again, that is ionic and it's aqueous, so it's going to split into ions. Potassium chloride contains the potassium ion with a plus charge and the chloride ion with a minus charge. Again, there's a big 2 in front, and when I split it, I've got 2 potassiums and 2 chlorides. Then I get to Br2, that is covalent, because I've got 2 non-metals. If it's covalent, it doesn't split. And what I can do then is I can cancel my spectator ions. My spectator ions are the ions that are exactly the same on both sides. Cancel, cancel. And what I'm left with is my ionic equation. The reason I'm able to cancel out those potassiums is the potassium's not actually involved in the reaction. When you have a chemical reaction, things lose or gain electrons. Potassium has exactly the same charge on each side. It hasn't lost electrons, it hasn't gained electrons, it's not actually involved in the reaction, it's just a spectator, as we say. Chlorine, as an element, has got no charge at all, but as an ion, it has got a -1 charge. So if it's going from a charge of 0 to a charge of -1, the minus tells us it's gained an electron, and if it's gained an electron, it has been reduced. So chlorine has taken a part in this reaction. It's gained an electron, it's been reduced. The bromide started off with a minus charge and ended up with no charge at all. So I can say that my bromide ion has lost an electron, and therefore it has been oxidized. So ionic equations are really useful for being able to see what has lost electrons, what has gained electrons, and in the case of potassium, what hasn't been involved in the reaction at all. I'm going to do one other one and then I will get you to practice yourself. So I'm going to take NaOH, aqueous. I'm going to take H2SO4, aqueous. I'm going to be forming Na2SO4, sodium sulfate, and I'm going to form H2O, which is a liquid. So this is an acid-base neutralization reaction. So the moment it's not balanced, I've got a 2 there. I need to have a 2 there, so I've got 2 sodiums on each side, a sulfate on each side, 4 hydrogens. I've only got 2 there, so I need a big 2 there, and then I've got 2 oxygens there and 2 there. Now I've got my balanced equation. So I'm going to write the ionic equation for this. I'm going to start off, do I have an ionic or do I have a covalent? And it's ionic, and this is aqueous, so it is going to split into ions. What ions is it going to split into? Now what some students do is they try and split the sodium, the oxygen and the hydrogen. Sodium hydroxide contains the hydroxide ion. I'm not going to be splitting it into oxygen and hydrogen, I'm just going to be splitting it into Na and OH. And the charge on my sodium is +1, the charge on my hydroxide is -1. And again, because I've got a big 2 in the front, it's going to be a 2 in front of the Na and a 2 in front of the hydroxide. So sodium hydroxide splits into hydroxide ions, not into separate oxygen and hydrogens. I'm going to see something similar here when I get to sulfuric acid. So H2SO4, it's covalent, hydrogen, sulfur, oxygen, they're all non-metals. But remember that acids are always aqueous and they will always split into ions, and sulfuric acid is an acid. So what ions is it going to split into? I've got hydrogen and I've got sulfate. So hydrogen is going to be H+, and my sulfate ion is SO4 2-. How many hydrogen ions do I have? Well, I've got H2, I've got 2 separate hydrogen ions, but that 2 refers to the hydrogen, that 2 does not refer to the sulfate. And I've got no big 2 in front, so I've just got 1 sulfate ion. So 1 sulfate ion and 2 hydrogen ions. You'll see then that that's how the charges end up cancelling. If I come over here to the other side, I've got an ionic compound, sodium sulfate. Again, it's aqueous, so it will split into ions. And again, I'm not going to try to split sulfur and oxygen. When you see your polyatomic ions, which you need to learn off by heart, you never split them up. So it's going to split into sodium and it's going to split into sulfate, but those SO4 is going to stay together. Sodium ion has a plus charge, the sulfate ion has a -2 charge. Na2, I've got 2 sodium ions. That 2 only refers to the sodium, it doesn't refer to the sulfate. I've just got 1 sulfate ion. And then at the end, I've got 2 H2O. H2O is covalent, it's not going to split, and I get 2 H2O at the end. Now again, I'm going to cancel out my spectator ions. So my Na plus is exactly the same on both sides. It's not involved in the reaction, it can cancel. My SO4 2-, exactly the same on both sides, it can cancel. And I'm left with 2 OH- and 2 H plus goes to 2 H2O. And because I've got a 2 in front of everything, I can actually, I mean, you could write that and you'd definitely get your marks, but you could get rid of the 2 and just write OH- and H plus goes to H2O. And this is what we're expecting. This is the ionic equation for a neutralization reaction. So that was the answer I was expecting once I had the whole thing worked out. Have a go. Have a go at doing B and C for yourself. Okay, so have a go at doing B and C. Press pause, write both of those equations as ionic equations. Okay, and I've got the answers for B and C here. So the first one should be Cl2, 2I-, 2Cl-, and I2. Okay, if you didn't get that, rewind, go and look at the first example I did, because this example B is exactly the same. The second one, C, you should get OH-, H plus goes to H2O. So you end up with the same ionic equation as what I worked out. Because you've got an acid and an alkali, this will work out always as your ionic equation. Again, with that one, when you've got the sodium hydroxide, you're splitting that up into Na plus and OH-. You're not trying to separate the O and the H. Okay, and then HCl is an acid. Because it's an acid, that will also split up into H plus and Cl minus, and then you'll be able to cancel that with the ion on the other side. If we look at another example, okay, I'm going to do a slightly harder one. Right, no, I'll do that one. Right, I'm going to do this one. I'm going to do a slightly harder one. I'm going to take Na2CO3, sodium carbonate, aqueous, 2HCl, aqueous, 2NaCl, aqueous, H2O, which is a liquid, and CO2, which is a gas. So this is another example of a neutralization reaction. So I'm going to follow exactly the same process as before. I'm going to start here with my sodium carbonate aqueous, and it's an ionic compound and it's aqueous, so it will split into ions. Sodium is in group 1 and it's got a +1 charge, and again I've got the carbonate. I'm not going to try and separate the C and the O. Carbonate is one thing, and a carbonate ion has a 2- charge. When I look at the numbers, I've got 2 sodiums, but that 2 only refers to the sodium because it comes after the sodium. It doesn't affect the CO3 at all, so that's going to be my ionic equation. Then I get here HCl is covalent, but it is an acid, and acids can split into ions. It will split into H plus and into Cl minus. But this time I've got the big 2 in front, and that means that the 2 is affecting the hydrogen and it's affecting the Cl minus. I get to the other side and I get NaCl, that's ionic, and it's aqueous. So I'm going to get Na plus and Cl minus. Again, because that big 2 is at the front, it affects the sodium and the chlorine. Next up, I've got H2O. H2O is covalent. It's not an acid or anything like that, so it's just going to stay the same. And CO2 is covalent, and it's not an acid, therefore it's going to stay the same. And then I cancel my spectator ions. I lose the sodiums, they're exactly the same on each side. I lose the chloride ions, they're exactly the same on each side. And this is what I end up with. H2O and CO2. And that is my ionic equation. Have a go. Boom. So I've just done B. Have a go at doing A and at doing C. So I've done B, you have a go at A and have a go at C. Press pause, have a go for yourself, and then press play. Conveniently here, I've also given you all of the formulas of your polyatomic ions, so make sure you're using that when you're splitting up your compounds into ions. Alright, so here are your answers. The first one, potassium hydroxide, splits into K plus and OH minus. Again, that OH is staying together, it's your hydroxide ion. And over here, nitric acid splits into H plus and NO3 minus. So polyatomic ions stay intact, do not try to split them up. Same on the other side, potassiums cancel, the nitrates cancel, and you are left with the following, which is your ionic equation for neutralization. I did that B for you, and then you move down to C. Ammonium hydroxide, you've got 2 polyatomic ions. You've got the ammonium ion and you've got the hydroxide ion, so that's what it's going to split up into. HCl is covalent, but it's an acid, so it splits into H plus and Cl minus. On the other side, I've got my ammonium ion and my chloride ion this time, and I've got H2O, and again the ions cancel and I get exactly the same answer as part A. I'm just going to do one more. Which I had here a second ago. Yes, sorry. I'm going to do one more. This time I'm going to do magnesium carbonate, MgCO3, solid, plus H2SO4, aqueous. Hold on a second. Sorry, I'm distracted. I'm going to pick up MgSO4. I'll change the colour of the pen. H2O is a liquid, CO2 is a gas. So in this one, I'm starting off again with MgCO3, because I'm starting off with an ionic compound. However, this time, my ionic compound is solid, and when it is solid, it does not split into ions. So that MgCO3 is going to remain in exactly the same condition. Then I get over here to H2SO4. Yes, it's covalent, but it is an acid, and acids split into ions. Acids always give you H plus, and in this case I'm also going to get SO4 2 minus. That 2 refers to the hydrogen. I've got 2 of them. It doesn't refer to the sulfur. I get to the other side, I've got magnesium sulfate. This time it's aqueous. So I've gone from solid to aqueous. This ionic compound will split up. Magnesium is in group 2. It gives me plus 2 ions. Sulfate is SO4 2 minus. Again, you don't split up your polyatomic ions. That stays intact. And then I've got H2O and CO2, which remain unchanged because they are covalent. Cancelling was the same on each side, SO4 and SO4, and the rest of it, what remains, is going to be my ionic equation. Let's see if I have another example of that. I do. An example here for the exam questions. You can have a go at this one. Oh, actually, we just did this one, did we? Well, essentially, this is what it looks in the exam, okay? Just like I've done, they've given you the equation, they've given you all the state symbols, they've asked you to write the ionic equation. So just press pause and have a go at filling that one in for yourself. Okay, and here's the mark scheme. This is the answer that you should have gotten. They tell you get 1 mark for having the left-hand side right, 1 mark for having the right-hand side right, and if you have it all balanced, you get a 3rd mark for balancing. So this is what it should work out as. I'm just going to get you to do one more, another one of the exam questions. So again, they've written the question out for you, they've given you the state symbols, they're asking you for the ionic equation. So have a go at doing question 3. Okay, so in question 3, this should be your answer. Your MgO does not split because it was solid, that's why that stays intact. The acid and the salt did split up, you cancelled out your spectator ions, and this is what you were left with. Again, 1 mark for the left hand side, 1 mark for the right hand side, 1 mark for balancing, 3 marks in total. Right, the other way they can ask you about ionic equations, and you'll see a lot of this on paper 2 in particular with qualitative analysis, is they'll tell you, write the ionic equation for the reaction of a calcium ion with a hydroxide ion. And in this case, you'll just write down the formula of the ions, the Ca2+, your calcium, and your hydroxide ions, and you'll write the product when those two ions react together. So all I'm going to be doing, if I put these two ions together, I've got 2 plus, I've only got 1 minus. That means I'm going to need to put my OH in a bracket and write my formula for calcium hydroxide. Similarly, they could say, right, you've got an iron 3 ion, write down the equation when it reacts with a hydroxide ion. You'll write down your formula for your iron ion, your formula for your hydroxide ion, and then you'll write what is formed if you react the two of them together. So in this case, they're not giving you the rest, they're not telling you what compound you're getting the calcium from. Okay, you could be getting that from, you know, calcium nitrate. Okay, they're not telling you what the compound is, they're just telling you you've got a calcium ion. They're not telling you where you're getting the hydroxide from. It could be sodium hydroxide. Okay, they're just telling you that these are the ions that react and this is what you end up forming. So essentially they remove the spectator ions from the question and they just include the ions that actually react. There's loads of exam questions on this and I would really recommend doing them. Here's just one example of a question. You're asked to write an ionic equation. It looks a bit random, but if you read through it, it's actually not that bad. It says you're reacting calcium carbonate with some magnesium ions and you're forming this dolomite. Like, I've never heard of dolomite before, okay, but that doesn't matter. They want you to complete the equation. They've given you most of it. All you need to do is fill in where they've got these dotted lines. So what are we reacting our calcium carbonate? Well, we're reacting it with magnesium ions. And because we're reacting them with ions, we need to show the charge. Okay, they're specifying it's ions, so I'm going to write my Mg2+, and that gets me a mark. And then these dotted lines suggest that it's not fully balanced, so I'm going to have to go back and balance it. I've got 1 calcium, but I've got 2 calciums on this side, 1 there and 1 there. So that suggests to me that I'm going to need to put a big 2 in front here, so I've got 2 calciums on each side. If I do that, I've got 2 CO3s as well, but I've got 2 CO3s here, so that's balanced. 1 magnesium, 1 magnesium. My equation is now balanced. There's a stack of exam questions on equations on Show My Homework. There's full equations and ionic equations all mixed in together. Do all of the ionic equations because they can ask them in, you know, slightly different ways sometimes. Sometimes they might ask you for an ionic equation when they haven't given you the full. In those examples, I would recommend writing the full equation first if they've given you all the reagents and then turning it into an ionic. In other cases, they'll just tell you to react one ion with another ion. That's generally a little bit more straightforward. But if you do have any questions about any of it, let me know.